This diary will contain all the topics required before advancing to the main subjects. So please listen and see carefully. All the best. Topic 8: Power dissipation across electrical elements. Now let us see voltage, current and power waveforms in a purely resistive circuit. Here V equal to Vm sin omega t, and we will draw waveform for V with orange color, of current I with green color, and power waveform P with dark pink color. The waveform of voltage is as shown on the screen. As this is a purely resistive circuit, the current and voltage will be in the same phase. So the waveform for current is as shown on the screen with green color. Now we know power is equal to V into I. So let us see the waveform for P. Now listen to me carefully. For first half cycle, V and I are both positive. So power waveform will also be in the positive. So V into I is positive. So the waveform is as shown on the screen. For the next half cycle, V and I are negative. So V into I is positive. So therefore the power waveform will be as shown on the screen. Now note that the frequency of this power waveform is 2f, where f is the frequency of the voltage source, that is Vm sin omega t. Now we will take purely inductive circuit as shown on the screen. The voltage source is Vm sin omega t and the voltage waveform is in orange color, current will be drawn in green and power waveform with dark pink. This nomenclature will be followed for the next circuit also. So here the point to notice is that since it is a purely inductive circuit, the current I will lag the voltage by 90 degree. To understand this concept, I request you to watch my video Sine Wave Phasor. The link is given in the description. Please watch that video before watching this video. Okay, so the voltage waveform is drawn as shown on the screen. The current waveform is drawn as shown on the screen, that is lagging voltage by 90 degree. Now see the time period up to 90 degrees, that the voltage is positive and the current is negative. So power V into I will be negative. Therefore the power waveform starts below, that is in the negative portion. Similarly, for the next cycle between 90 to 180 degree, V is positive, I is also positive, so V into I will be positive. So the power waveform goes like this. Similarly, the power waveform is completed. Note here also that the frequency of the power waveform is twice the frequency of the voltage source. This is important. Hope you get how the waveforms are drawn. Now note carefully that in the purely resistive circuit, the average of the power waveform is some finite value, as all the waveform is in positive. But in purely inductive circuit, the P average, that is the average of the power waveform, is 0, because the part that is below the x-axis is equal to the part above the x-axis. So positive and negative cancel each other. So the average is 0. That is, actually no power is dissipated across the purely inductive circuit. This conclusion is very important. Now let us take a purely capacitive circuit. The voltage source is V is equal to Vm sin omega t, and now we will draw the waveforms for V, I and P. So the voltage waveform is as shown on the screen. Here the current I will lead the voltage waveform. So the waveform for I is as shown on the screen. Now see, for the time period 0 to 90 degree, that V is also positive and I is also positive. So V into I is positive. So here the power waveform starts above the x-axis. So the power waveform goes like this. Now from 90 to 180 degree, the current waveform is negative and voltage waveform is positive. So power is negative. Therefore the voltage waveform goes like this. Similarly, the cycle is completed. Here also the frequency for the power waveform is twice the frequency of the voltage waveform. And notice carefully, the power average here also is 0, because the part of the waveform that is above the x-axis is same as the part that is below the x-axis. So the average is 0. So this is very important. Conclusion: power is only dissipated across resistor. This is because the P average in the resistive circuit is a finite value, as we have seen in the discussion, but the P average in capacitive and inductive circuit is 0. So the power is only dissipated across resistor.